So, continuing on, since you guys were good with yesterday, we're going to continue on with the 1.7. We're going to be working with combinations of functions. That's the other thing you should know, or what's called a composite function. What we'll be doing is we'll be probably adding, subtracting, right? Performing operations on some of them. And sometimes we'll do composite functions. That's when you do I need to get that exhibit meme too, where you put functions in your functions, so you can graph those functions while working on functions. So today we're going to be working on domain of a function. We've kind of did that a little bit already. We're going to combine some functions and then talk about their domain, form composite functions, determine domains of composite functions, and write those functions as compositions. That was a mouthful. Alrighty then. Finding the domain of a function. If the function f does not model data or verbal conditions, its domain is the largest set of real numbers in which the f of x is a real number. That means that I'm searching down my x's, right? And as long as that every x has a y value or an f of x value, then that's in the domain. Kind of like when we looked at ordered pairs, right? You guys remember when we did ordered pairs, all the x's are domain, all the y's are range, okay? So as long as some part of it exists, so let's say I kind of had 1, 2, 3, 1, 2, 3. I don't know, maybe it looks something like this. Well, this function only exists on the values of x from -2 to a +2. Therefore, that would be my domain. Okay, that's what it's saying. Questions on that? Okay, cool beans. Can I change the slide?
Wait.
What's up?
How would you write that in
Interval notation? In interval notation? Well,
just parentheses?
I got to make sure that these are going to be done. No, this would be a bracket. Now, if this was an open circle, let's do that just for the sake of it. We're going to go -2 to 2, and then parentheses. On the test that you guys took a bit ago, one of the biggest things that I saw was people didn't know when to do parentheses and when to do brackets. If you're talking about the intervals of increasing and decreasing, you will never use brackets there. It's all parentheses, okay? So it's only on the intervals of increasing and decreasing. Domains, the intervals for domain, and yes, you want to make sure that you tell whether it's part of it or it's not part of it, okay? Someone lost something there, okay? Correct. Correct. Alrighty. Excuse me. Let's move on. Finding domain. Finding domain. Now, I think we've said before, if this was just a polynomial, then I would be okay. I mean, just about anything you can throw into a polynomial and you would get some number for it, right? People are hurting. This is chapter P stuff. Are we bringing back memories? Bad memories? The only thing that I have to be careful with this rational equation here is my denominator. My denominator would create problems for me, wouldn't it? Because I know that I cannot have 0 in the denominator. So what I have to do is ask math, hey math, please tell me when x squared minus 49 is equal to 0 so that I can say these values are not part of my domain. Does that make sense? So we can see that this is the difference of squares. So that's going to factor into two, what do we call these guys? Conjugates. So we're going to have a +7 -7. And then we use our zero product rule, right? If I have some number based on closure times another number based on closure, then one of those two have to be 0, if not both of them. So then the question is, well, when would this first number be equal to 0? When x is a -7. When would this next number be equal to 0? When x is equal to 7. So in both of these cases, they would produce problems for me. So I can say, hey, you know what? I understand that I can be any number, but because there's a couple of options that will give me a denominator of 0, these two guys can't be my denominator. So I could just say, hey, you know what? How about set builder? You guys cool with that? Domain. Any real number except x cannot equal ±7. Okay? If we're going to do interval notation, we will be coming in from -infinity, right? We would go all the way to -7, and then we couldn't be 7, and then we could be anything from -7 to 7, and then I could be anything from 7 to, oops, to positive infinity again, where I'm jumping the 7 and the negative 7s. Okay? Yeah, I know it's a little bit more cumbersome. I really like set builder because I can kind of do whatever I want with that piece, as long as I can convey the idea. But you have to know how to use that interval notation as well. Now, there are no parentheses here because, can I ever be equal to infinity?
No.
No, on either end. And of course, we already said that we can't be negative 7 or positive 7, so I'm not equal to those. Thank you, boss. Riley? So in this case, the domain is all numbers except for 7 or negative 7. Okay? All right, here are some rules real quick. I think you guys have seen this notation before, right? If you can't see it very well, this first one, if I want to add two functions, I would just say, hey, I want you to add f and g of x, so I can write it this way. I'm telling you to add two functions. I can ask you to subtract two functions. Now over here, be aware that you're adding, so the order in which you add them doesn't really matter, right? What rule tells me that? The commutative property. Does it matter here? Yes. F minus g will not give you the same function as g minus f. Okay? So you want to be very careful with that. If I want to multiply 2, then you'll have fg of x. And of course my division would be f over g of x. So we've got some basic operations going on with our functions here, okay? Do I really need to say much more about that?
No, sir.
The only thing I do want to be careful with, this is now a ratio. G of x cannot equal 0. Cool. All right, moving on. All right, let's operate. Oh no, I put them stuck together. Let's operate on these functions. I want to take f and add g to that. So I'm going to go x minus 5, and I'm going to add to that x squared minus 1. Therefore, f plus g will end up being x squared plus x minus 6.
That's the difference.
That makes
Right?
sense.
Shouldn't you have like factored that out first? 'Cause that's the difference of square.
No, I don't need to factor it out.
Because you're sad.
All I'm doing is combining two functions. I did that kind of fast, so I need to do it again? Sorry. Put your pencils down, please, when I'm doing this, and then I'll let you guys take all the notes that you want. Okay. Because then that way you don't miss what I'm doing, and then you can ask questions. Because I do kind of do it pretty fast. It's my bad, my years of experience. My first function is f, which is x minus 5, correct? And I'm going to add to that the function x squared minus 1. So when I combine them, I'm going to end up with x squared from this guy. I can't combine it with anything else, so it's just x squared. I don't have any other x's, therefore this is plus x. And then I'm going to add my constants at the end, or combine my constants, which is minus 6. And that's all it is. What's up?
Why isn't it like 2x squared? Oh, never mind. That was so
Caught yourself. Good. No, it's not.
That was very
You're good? Okay. Now the question is, what is the domain of f plus g of x? Yeah, I really can't go wrong with it because there's no denominator, is there? Okay? So whenever it's something like this, I really don't have to worry about it. I can just say that the domain is the set of all real numbers. Huh?
Can you redo the R real quick?
I just do 2 lines and then put the r through it. It's all real numbers.
R is real numbers.
Oh, yeah, that's kind of the way it works.
That's kind of like the way it works.
Guess what n is for? Evan? What is n for? The natural numbers.
I'm tired of you.
I quit you. Calling the police. All right, cool. Questions on? Oh, I erased that. Any questions here? Any questions there? Because yeah, I mean, if you take a look again at what we composed, what was at the end, there really wasn't anything that was going to break my function, right? Nothing that would be like, what happened here? All right, moving on. Oh, this is the good stuff. Yeah, take your stuff, just in case. Or do you think you'll be back? All right, cool. Then don't.
Do you know where B122 is?
Where what?
B122.
It's in the front office.
That's the front office, sir.
It's in the front office. All right, composition of functions. Sometimes I'll refer, this is read f of g of x, okay? Sometimes I will refer to it as fog or goth, or depends whatever the word it is. There's more than one notation, please be aware of it. In this case, the main function is f, and we're gonna plug g into that. Here's the other way we can notate it. You can see that?
Whoa, hold on. And that's another way of writing it?
Right, so if I have f of g of x, I'm taking the g function, it's going to get plugged into the f function. And you can probably see it a little bit better if I wrote it like this. Right? I'm taking the g of x function, and I'm throwing it into the f function as my new value.
That's where
Okay? Oh, I missed something, sorry. Alright, you guys good?
Yeah. See, I was solving g of f of x. I was going the opposite way.
No, you always go, we read our math left to right. So when you start there, the first thing that you see is the main function. That's what you begin with. And then you're going to throw stuff into that. Kind of like Russian nesting dolls, right? Dot, 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 dot. You just throw them in.
Yeah, alright.
All right. So, thank you. I also want to point this out. Do you know how addition and multiplication are commutative, right? Composition of functions like this is not commutative. F of g does not produce g of f. Okay? So be careful with that. Okay? Unless you're doing like f of f,
It's not
then yeah, it doesn't really matter. And yes, sometimes they'll make you do FOF. Okay. So please, thank you. Watch me do this. And then you can write down the notes. I mean, at least you're doing it twice, right? Once with me, and then once you're doing it on paper. So, we're going to compose f of g, which is my main function. F. So I'm going to start with 5x plus 6. That is my main function. So I'm going to write 5x plus 6. Every parenthesis in my main function, we got to put something into it. And what is that something that we're putting in there? The g function. This, my friends, is the g function. 2x squared minus x minus 1. So we've got
10x squared. X squared minus 5x times y plus 6. Plus 1. 5x squared minus 5 plus 1. Mr. Munoz, I think I just got my first math problem right.
That's good to hear. So there we go. Go ahead and try to do that on your own again.
Do you want to give us a new problem or the same one?
That would be cool.
Give us a new problem. Can I have a new problem, Mr. Munoz?
As soon as you guys copy this one down.
Oh, okay, I see.
Where's my cafe fake?
There you are.
There's my cafe fake.
Do you get a Circle K coffee or
Mm-mm.
what type of coffee? do
Fresh
you
brewed
get?
at home.
Oh, I see.
This one in my cup is Dunkin's.
Dunkin'?
Yesterday's was Starbucks.
Never had that.
What's your favorite actual coffee from Dunkin'?
I don't know. This is the only thing I've had from Dunkin'.
Oh, and it's not even from Dunkin'.
Well, it's their product, but it's not.
Mr. Munoz?
See, the thing is that like whenever I go to any place like Starbucks or Dunkin' or even McDonald's, their coffee just isn't strong enough. It's not black
Oh,
enough.
boy. Whoa. Is that right?
I like it bitter and dark, and
Yeah, I feel it.
it matches my soul.
Actually, I do not feel it.
What's up, Bailey? Of course.
Oh, God. One sip of Mr. Munoz's coffee and we'd all be superheroes.
My dad was mad. I gave him some of my coffee from Starbucks, and I like their Sumatra. Their Sumatra is like intense.
Yeah.
He spat it out. He's like, "You're giving me tar." I'm like, dude. I'm like, no. I bought a coffee. I mean, why am I gonna put tar in?
We would grow like third arms if we drank your coffee. We would become mutants, man.
Oh, the one that's like floating. Yeah.
you like that? I love everything.
Like I said, the only thing I can't listen to
Oh, you don't have
is gospel.
I'm
I'm sorry. I tried to do some POD. Yeah. I was like this. I'm like,
well, on
Taylor, go through.
hey, almost crashing into 6 different cars. God is literally behind the wheel. You know that one song, Jesus?
no, it was my Tesla. Okay. Thank you. Let's clear this. Here's your, I want you to calculate G of F for me, please. Calculate G of F of X, please.
Are we supposed to be doing this?
No, actually we're not.
No, for Friday, you know.
Oh boy, how are you? I don't know.
Wait just a second.
So this would be 12 squared. No, you squared. I'm sorry.
You gave us some lunch order.
So it'd be 25x
Wait, you put G into F, or G into F.
with
G, F is the G. The G is the main function. It's the first one on the row. That's the main function.
Because look, 6 times 5 is 30, right?
Well, why? No, it would be 9. Oh, you're doing it.
Okay, that's okay.
Well, then why is your tree still on the outside?
Distributed it.
Well, then how did you get that?
Because look, 5 times 6 is what?
Tell me you don't think
Do I square first or do I distribute first?
Yes, they're squaring it first. That's what you square first. Just literally doing this.
Are you done? That's my question.
Are you done? That's literally what you done. You square the 5x, and therefore the x is squared.
Is that starting now?
Yeah. Like, did you solve it yet? Yeah, of course I did. Do the math. Did you let you do the math?
Do the math, bro. Do the math.
I already solved it. Oh, yeah, yeah. I got the Dude, let's go! You guys did this? No.
And when you did just like, no, you guys are just like,
Wait,
I don't think you.
no,
I don't think you just.
Remember 66 plus 5.
Oh, I forgot about the
Yeah, the tool was like that first. It's T. With a little bar above it.
I got 50x squared.
Yeah,
That's definitely.
We're missing.
we 6 times 2.
Where did you get 66 from?
I see what I did wrong.
I'm telling you my exercise. That should be one of the okay, you're supposed to have 230 add together. Tell me where I went wrong, because I don't think I went wrong.
Thank you.
Is that
Cool. Good job working on that. What is my main function in this problem?
G.
My G function. That means it's my 2x squared minus x minus 1, yeah?
Yeah.
All of my x's will now become a set of parentheses so that I can plug something in. And what am I plugging into this? What am I plugging in?
F of x plus 6.
The f function, right? Which is 5x plus 6, 5x plus 6. And at this point, it's just a matter of simplifying it. So we've got 2 times 25x squared plus, not 30, Gotta double that. 60x squared plus 36.
It's not x squared. It's
JK. JK. Minus 5x minus 6.
No, it'd be plus 6.
No, you gotta distribute that.
Okay.
Minus 1. Right?
And then it's minus 7, right?
So we've got 50x squared
Plus 120.
plus a buck 20. What is that?
72.
Plus 72. Minus 5x. Minus 7.
And then it becomes 50x squared plus 115x plus 65.
And there, my friends, is
Hey, Mr. Miller,
G.
I was finally
Good. There you go.
I got that, and you all were doubting me.
You got that. Give yourself a pat on the back.
He copied me. He copied me. That's plagiarism.
No, that's you teaching him. Good job.
My soul back.
I was gonna say Mr. Regular. I'm gonna go with Mr. Regular.
Okay.
What's knowing that?
Try it one more time. Oh, are you writing?
Yeah.
I'll pause for you.
Do you mind if I take a quick?
Go for it.
Take a pig.
Find the map. Find the map. Find the map.
Alright, you're good. Yeah, the last like 6 pictures.
All right, try this now.
The board you were scratching.
Go back. I'm sorry. I thought you were done.
So I have pictures.
My bad.
No worries.
So minty. Smells fresh, huh?
It smells like olive oil and mints. That's what me and Evan said. Like something I can see.
You know which mints I like? The ones that are kind of like chocolatey and they kind of dissolve in your mouth.
Like the swirl ones? Yeah. And they come like individually packaged.
Yeah. All right, try this. Try this.
I can.
God, so we can have
No. Bro, why you add fractions? That's gay.
Hey, watch your words, please.
Yeah, someone says.
Yeah.
Can I find that?
Especially since we're recording this live
Oh.
live in front of the studio audience.
in front of a classroom audience.
Mr. Watson.
1 minute?
Killing it, Munoz.
1 minute, she fine.
Anything else you can do?
Yes, there is. You're just not thinking. You're just not thinking.
Wait, so we're putting the f of x into the g, right?
No. G is the F is the main function. It's the first one, and you're gonna plug in the G function into that.
You guys got it right so far. Yes, that's what I said.
Yeah, for so we're two x plus one, but like that could be so wrong. But it makes sense.
That would be 4.
Yeah, just take it out. Just take it out. Yeah. Just take it out. Yeah. Yeah. We don't need x. Yo, hold up. Wait. I wasn't ready. I'm on this one.
Got it?
I'm a phantom, but it looks like
You substitute
So I've been trying to find a song
into the
from the
x
90s.
of f of x.
I don't know if it was the 90s.
And
This
then
one
my
is
name
that.
is from
But I think it's
Yo,
G.
yo,
And he was like, I got what I should
I think I got it. But I don't think I know.
No, because mine I got.
Mine's a C, it's one fraction.
Yeah, that's what happened.
And I think everyone's just doubting me. So
So you multiply this
should be. That's not right. What's
It's
that?
plus 2.
Okay, so it should be 1 plus 2.
That's one.
We all got, I got 2x minus 4.
Now I can see.
2x over
Mine
to
is
multiply simple x. Look, if you multiply both of these by x, so then these x is canceled.
2x plus 1, I got that. And you all were doubting me. Nobody was doubting you.
Wait, she actually did
I
it
told
right.
you, I told you I got it.
I'll do it up there. Alright, so.
I told you I got it.
I know.
Oh, were you using the force?
No, I was just saying.
Oh, I thought she was like,
She parts all the
this is not the student you were looking for.
That's what
Oh my gosh, so long. Thank you. So, I think that everyone got the first steps good. My main function in this case is 4 over x plus 2. What's getting plugged in? The 1 over x, right? My recommendation to everybody is ignore the 4 for now. Get this to be a single fraction. This fraction is going to have a denominator of x, correct? That means that this 1 didn't change, and that 2 would have to be multiplied by x in order for it to match.
Wait, what do you mean?
That too fast? Sorry, I'll do it again.
Why would you complicate it like
Get rid of x.
Complicated?
Yeah,
I feel like I
just
did
multiply
mine
by x over x to
Yeah.
factor it out.
Show me.
No, I'll show you because I actually got the answer right.
So you multiply by x over x, and then this becomes 2x,
You could just multiply it.
and then that becomes 1 plus 4, and then that becomes 4x. Right? I mean,
I like that. Good job. So, what happened?
He left you hanging.
Oh, it's okay. He didn't see me. High five. So I like this. This is really good. It really depends on how you. Thank you. So it really depends on how you see things. Like for me, this all I really have to do because I know my denominator is x. I got 1 plus 2x. Okay. I really like what he did because you do save yourself a lot of work here. He figured out this denominator is going to be x, right?
Right.
Took the top and the bottom multiplied by x. Here's what happens. When you multiply your distribute out, these x's would cancel, wouldn't they?
Yeah, so.
So you would end up with x, with a 1, just a 1. Because x over x is gone. And then when you multiply here, you're going to get 2x. And then up top, you're going to get 4x. Which is exactly what we would have gotten once we multiplied by the reciprocal. Because this would just get kicked up here. Okay? So yeah, good job. I like that. I'm gonna use that. I'm gonna wait for him to graduate and I'm like, look at this better idea. So either way that you were taught, you should be a method for you anyway, regardless. Alright, cool. Thank you. There were 2 methods up there. I just want to make sure that you got one of them and you're okay with it. So let me see those thumbs up, thumbs down.
I understood that one.
Alright, cool beans.
Beans were not cold.
So, what we did was the composition of functions. Of course, there's also going to be a decomposition, right? Just like when we distribute, what's the opposite of distributing? Factoring. When we compose, we have to decompose. So when you form a composite function, you compose 2 functions to form a new function. It's also possible to reverse the process in what's called decomposition. Okay? So here we go. Express h of x as a composition of 2 functions, which is here. If f of x is the square root of x and g of x is x squared plus 5, then what is f of g, which is h of x?
That makes sense. Yeah.
Okay.
Yeah, that makes sense.
Can you see it? Yeah. The main function in this case was f of x, which is the square root of something. And what was that something? X squared plus 5. So you got to be able to take this and break it up into its two pieces,
And then that's
right?
yeah.
Which is not really that crazy.
Oh, so the answer is f of the square root of x and g of x.
Yeah, so the decomposition of h of x is f of g.
Oh,
And where f is the square root of x, and g of x is x squared plus 5.
that actually low-key makes sense.
I thought I had an example for us to do.
Dang.
Alright? Cool beans. I'm done.
Wait, that was it?
Wait, what?
Yeah.
Yo, wait,
We get a practice.